Okay, so 9.1, right triangle trigonometry. And when you look at these pictures, when you do your assignment and stuff, you need to look for the angle that they've marked. It says, like, how do you find the measure of the angle? And then it has this symbol, that's called theta. It's called theta. It's just a symbol, like angle, instead of angle x, it says angle theta. It's a symbol for the angle they're talking about. So if you look at the picture over here, see they're going to be talking about this angle in the corner, this theta. Now some of you might have heard of a little phrase called SOHCAHTOA. SOHCAHTOA. And I wrote it up here. S-O-H, so, C-A-H, ka, T-O-A, toa. It's, I don't know, people just use it to remember the trig functions. They just use it as a way to remember. So, the S stands for sine. Stands for this word sine.
That's a weird way to spell sine.
Yeah, it's S-I-N-E in trig. Sine, S-I-N-E. So sine,
Spell like you don't want to get copyrighted.
sine equals opposite over hypotenuse. The hypotenuse is the longest side of the right triangle. I think a lot of you know that already. Hypotenuse is the long side of the right triangle. It's across from the right angle. So when they say so, this, like again, where I have this SOHCAHTOA, see S-O-H, so, S-O-H, see it's opposite over hypotenuse. I'm writing it out over here, but yeah, it's sine, S, so, is opposite over, sine is opposite over hypotenuse. The next one down is cosine. That's the ka, C-A-H. Cosine is adjacent over hypotenuse. And the TOA, T-O-A, the T stands for tangent. Tangent is opposite over adjacent. So it's referring to the sides of a triangle. The hypotenuse is the longest side of the triangle. And when they say opposite, that's like across from. So we have the picture here. See, like here's the angle I highlighted in yellow. And then across from it, see, is opposite. The word opposite means across from. Hypotenuse is the longest side across from the 90-degree angle. And adjacent means next to. See, like this, where they wrote adjacent, see how it's kind of like really close next to the theta angle that they were talking about? So you have to know, like, opposite's across. Opposite's always across from the angle they're talking about. Opposite. Because you have to know which one to look for when you're looking for opposite. You got to know, oh, I'm looking across. Opposite means, like, look across from the angle. Adjacent is next to it. Adjacent means like next to it, like beside it, next to it. Hypotenuse is always the longest side, across from the 90-degree. So have you heard of some of those things before from geometry? Yeah, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. They put C-A-H, ka. Tangent opposite over adjacent. So those are probably the ones you've talked about in geometry. So that's what I was saying. Some of you probably know some of these. You might not know these yet. We're going to go over the other ones. There's 6 trig functions altogether. So we need to go over these cosecant, secant, and cotangent. Well, the cosecant one is like the opposite of this sine one. It's just like a reciprocal of it. So the cosecant one is hypotenuse over opposite. It's like flipping this one, flipping this first one. It's hypotenuse over opposite. It's a reciprocal. Reciprocal is like flip the fraction. The secant one is the reciprocal of the cosine one. So the secant one is hypotenuse over adjacent. And the cotangent one, that one should be easy, right? What do you think cotangent one is? Yeah, let's flip this tangent one around. Adjacent over opposite. Good job. Adjacent over opposite. Okay, so we wrote all 6 of them out. And like I was saying, it's kind of, you might have seen these keys on a calculator before too. But for sine on the trig function, sine is spelled S-I-N-E, but on the calculator it just says S-I-N. It's not sin, it's sine. I know, it looks like sin, but they say sine. It's not cos, it's cosine. It's not tangent, I know. But yeah, you see that and they say, oh, it's the sin key. No, it's sine. Sine. Yeah, so it's sine. They just put S-I-N on a calculator. Cosine looks like C-O-S. Tangent is T-A-N. So they just use 3-letter abbreviations for them. 3 letters. Sine, cosine, C-O-S, tangent. The cosecant one, they abbreviate it. They just put cosecant like this. They put C-S-C, cosecant. Secant, they put S-E-C, secant. And cotangent, C-O-T, cot. Cotangent. See, they just use 3 letters instead of spelling it out all the time. Yeah, they just use 3 letters instead of spelling that all out. Alright, so this cosecant one, again, it's the reciprocal of the sine one. So it's another, sometimes you might see in textbooks and stuff that they write it's the same as 1 over sine. Like this cosecant one, like I was talking to you about it up here, we just flipped it. It's the reciprocal of the sine one. You just have to flip the sine one around. But they write it like that sometimes, 1 over sine. The secant one was like flipping the cosine one around. So they put 1 over cosine. So just so you know, they might write it like that sometimes, but it means to flip it. It means to flip your sine or your cosine one around. And the cotangent one is like 1 over tangent. It just means reciprocal. It means to flip it around. Yeah, it means it's a reciprocal. It's like flip. Like if you know what the sine one is, you can just flip it around and you'll get the cosecant one. So that's kind of the definitions of it all. So let's try it now, like try an actual problem of it and see what you think. Okay, so that's all the definitions of it. So now we're going to try this example here. In a right triangle, this theta symbol, theta, they call that. That thing is called theta, T-H-E-T-A, theta. It's like just a missing, some value, missing angle. In a right triangle, theta is an acute angle. Do you remember what acute means?
Less than 90.
Yeah, it's some angle less than 90. Yep. So they're saying this in this picture over here, this theta is some angle that's less than 90 degrees. And then it says sine of theta is 4 over 7. Okay, so that's important. We have to use this. They're telling us sine of theta is 4 over 7. Well, if we look up here, sine we said was opposite over hypotenuse. So if they tell us this sine is 4 over 7, that gives us some information. So sine again, sine was equal to opposite over hypotenuse. So they're like telling us some stuff. So what do you think? So could I label my picture? What should I do with these numbers?
Before, the opposite of before.
Yeah, the 4 has to go opposite of this. Like the 4 has to go over here to the opposite side. 4 is the opposite. Does that make sense? And where would the 7 go?
On the top.
Yeah, on the top, the hypotenuse, the longest side. Good job, see? So you just label your picture based off of this. 4 is the opposite side, and 7's the hypotenuse, because they gave us opposite 4, 7. Hypotenuse 7. Alright, so we have it kind of set up, and it's a right triangle. So what if I wanted you to find this side down here? Could you do that? Find the other missing side. Do you know how to do that? You do something with the triangle. It's a formula you should know. Good job. A squared plus B squared equals C squared. So which side is always C? The hypotenuse. Yeah, 7, that's C. It doesn't matter which one's A and which one's B. The legs are the A and the B. Just pick, like, what do you want 4 to be A or B? It doesn't matter. Should we say 4 is A? It doesn't matter. This could be A or B. You just have to make sure the hypotenuse is always C. Yep, so C is the hypotenuse. You have to remember that. C equals hypotenuse. Every time. Remember that from geometry? C is always the hypotenuse. Okay, so we could do like 4 squared plus B squared equals 7 squared. So we could find that other missing side. That's like B. We'll say that's B. We're trying to figure that out. So what's 4 squared? 16. What's 7 squared? 49. Subtract 16 from 49. 49 minus 16. Okay, so B squared equals 33. How do you just find B? Square root, yeah. Take the square root. B equals square root of 33. Now we usually just leave it like that. So B is square root of 33. Alright, so we got the missing other side. We found it. Alright, now let's finish this problem up. So now they gave us what sine was. So they gave us sine was 4/7. They gave us that one. Could we figure out what the other trig functions, like what's cosine and what's tangent? And you just have to look up above at your notes. The cosine one is adjacent over hypotenuse. So which side's adjacent? Yeah, the number we just found, that square root of 33, that's the adjacent side. Yep, the 4 over here, see, is across from the angle, so that's the opposite. And this was the hypotenuse. So yeah, the B is the adjacent side we just found. So cosine's going to be square root of 33 over hypotenuse 7. See, it's going to be square root of 33 over 7. Okay, what about tangent? So all it is like reading these up here and writing the sides that you need, writing the correct sides that you need. So what should we put for tangent? 4 over square root of 33, okay. That's good. Okay, sine. Now, the other ones, these other 3, you're not as familiar with them, but they're just the opposite of the first 3 we did. So now we got to do cosecant, and write that one out. So cosecant, you just have to take the sine one and flip it over. So it's going to be 7 over 4. So what do you think, okay? And then secant's the next one. Secant is the opposite of the cosine one. So it'll be 7 over square root of 33. And then last one's cotangent. What's the cotangent one? Square root of 33 over 4. You flip this one. You just flip it over. So square root of 33 over 4. What do you think of that? Not too bad? Do you think I should make them rationalize it? Rationalize the denominator?
I would.
Yeah, I think so too.
Yeah.
So these are all good, but in math and mathematics, and if you keep going into college and take college math classes or pre-calc next year, they don't want square roots in the bottom of fractions. So the last step, if you have, like this tangent one has a square root in the denominator, you can't have that. So you have to times by square root over 33 over square root of 33. So it becomes, it's not really that much harder. It's just going to be 4 square root 33 over 33. It puts the square root in the top, and then the bottom, when you take a square root times the same square root number, it's just the number. Square root of 33 times square root of 33 is 33. Like when you square something, it gets rid of the square root. You actually should have done some of that in geometry last year, but I don't know if they did it or not. You're supposed to. When I taught geometry, we made them do it all the time. Yeah. So see at the end, I just times by that bottom number, so it becomes 4 square root of 33 over 33. So there's one more we have to fix. Which other one do we have to fix? The secant, it's just going to be 7 square root of 33 over 33. See how the square root just goes in the top over 30. It just gets rid of the square root in the bottom. You're just timesing by square root of 33 over square root of 33. When you times by that square root number, the bottom just becomes 33, plain 33. Because when you square something, it gets rid of the radical. Yeah, so technically you're supposed to do that step too. For the final answer. Yeah, I think we better do it because you have to keep doing. It's something they should have taught you at the end of Algebra 1. You should have done it some in geometry. By the time you get here, you guys should already know that. But I don't know how. You guys don't seem to remember stuff very well from Algebra 1 and geometry. Like higher level math, it just keeps, it keeps building. Okay, so let's try one more of these. This is asking you again to figure out these 6 trig functions for this picture this time. New picture, figure out what the 6 trig functions are. So they give you a picture off to the side. Which side's the hypotenuse? Which number's the hypotenuse?
17.
Yep, that's C. Now 15, you could call that A or B. It really doesn't matter. You have to find. So let's say this is A, and you have to figure out what B is. Like we don't know the B part right now. So you have to do your Pythagorean theorem again. A squared plus B squared equals C squared. So A is 15. The other leg, we don't know. C is 17. So you got to do your Pythagorean theorem. 15 squared is, big number, 225. 17 squared is 289. So you're going to have to subtract 225 from 289 and try to figure out what b equals. So 289 minus 225. So if I subtract those two numbers, I get 64. So what does b equal? What did you say, Kelly?
8.
Yeah, 8. You take the square root of 64 at the end. You know, something times something makes 64. So, yep, b equals 8. Alright, so this missing side is 8. We got it. So now we should be able to write out what the trig functions are, what the 6 answers are. So we're going to have to figure out sine, cosine, tangent. Write those 3. Let's start with sine. Okay, so it says sine of theta. See where the theta is in the picture? See the theta's up here? I'll highlight it in yellow. You have to pay attention to where the missing angle is, because you have to figure out which side's the opposite and which side's the adjacent. So which side's opposite of this theta?
8.
Yeah, this one down here, I usually draw an arrow across. See, that one's opposite. Yep, 15, this is the opposite. Good job. Drawing that arrow across helps. Across is opposite. So then, the C one's the hypotenuse, remember that. So that makes the B one the adjacent one. Now you should be able to write the six answers that you need. The 6 trig ratios. So opposite's always across. Alright, so what do you think? What's sine going to equal? The sine theta one.
15/17.
Yep, good job. 15 over 17. The opposite over hypotenuse. Good job. Okay, cosine one. Which one's that? Good job. Adjacent, that's the 8. Yep, 8 over the hypotenuse one, 17. 8 over 17. Okay, now we need tangent. Tangent up above says opposite over adjacent. So what's that going to be? 15 over the 8. Yep, good job. And I'm just going to keep doing it in the same order every time. So now I'm going to do the cosecant one, and then the secant one, and then cotangent. I try to do them the same order every time because, I don't know, it'll just help you. Because this cosecant one's the opposite of the sine one, the reciprocal. You just keep doing it the same every time. So if you flip around the sine one, that's what the cosecant one is. Cosecant is 17 over 15. See, it's the hypotenuse over the opposite side. And then the secant one, what's that? 17 over 8. And cotangent, 8 over 15. And it's not too bad, is it? That's pretty easy. Alright, so hopefully some of that was familiar. Maybe a little of it was, like a squared plus b squared equals c squared, and maybe a little bit familiar. And then on the back is 30, 60, 90 triangles and 45, 45, 90 triangles. The first one's a 30, 60, 90 triangle. These kind of triangles have a special relationship with their sides, and it has been proven in past, and you've studied it in geometry. So there's a relationship with the sides. So 30, 60, and then that little triangle, that little square in the corner, that means 90 degrees. I'm sure most of you guys know that. So that's what sees 30, 60, 90. So I usually start with the smallest angle in this one. The smallest angle in this one's 30. And across from the 30, that's obviously the shortest side. Right? It's across from the smallest angle, so it's going to be the smallest, the shortest side. Okay, so there's like a relationship here. The short side, I don't know if I want to do it with a variable or with or just the numbers. I don't know. It doesn't matter, but. So we have a short side, and then we have the hypotenuse over here. Across from the 90 is that hypotenuse side. And then this is the longer leg. So we have a short leg, a long leg. I could have called it a leg, short side, short leg. Short side, a little bit longer side, and a hypotenuse. Okay, so there's a relationship between these sides. If I give you a number for the short side, the hypotenuse is twice as long. So I'll put an x, like if this is a number, like if that was 5, if x was 5, then the hypotenuse is twice as long, it's 2 times as much. Do you remember learning that in geometry? This side could be a number like 5, so then this side's twice as much, this might be 10. And so you have to think of like what they give you first. Like what if I gave you the hypotenuse and you had to find this one? So you have to think like, oh, if I'm going, like if this was a number like 16 and I need this side, I have to divide by 2 and get 8. You have to think it's smaller. And then this side it's kind of weird. It's whatever this number is for the short side, and then it's times by square root of 3. So sometimes I've seen it like I usually write 1, 2, square root of 3. I've done it that way too, like without a variable. I write this is 1, this is 2, like twice as much, and this side's square root of 3, square root of 3 times as much. I don't know, maybe the variable will help you. I don't know. What do you think is more useful? I don't know. Yeah. It can go any way. Sometimes in textbooks you might just say they label this as 1, so this is 2, because you know, like 2 times 1, and this is square root of 3. So it's a relationship and you have to figure it out. So if you have to figure out, if they give you the hypotenuse, I usually go then take that and divide it by 2 to get the short side, and then times that by square root of 3 to get this side. You have to think of the relationship. We're going to practice some down below. Okay, so then there's another relationship with 45, 45, 90 triangles. Another special relationship here. Again, the long side's the hypotenuse. And when you have these angles that are the same, 45 and 45, then these legs are going to be the same amount. These are the legs, and like maybe that's a 4, so that would be a 4. If you know, maybe if they give you a value for those, they're going to be the same. The legs are the same. And the hypotenuse, you take it times square root of 2. If they give you a leg and you have to find the hypotenuse, you take the leg number times it by square root of 2. Like if this was 4, then this other leg would be 4, and this would be 4 square root of 2. But if they give you the hypotenuse, you have to divide by square root of 2 to get this side. Like if you go from, I'll write in like a red pen, like if you go from the hypotenuse and you have to find the leg, if you're going from the hypotenuse to the leg, then you have to divide by square root of 2. But if you're going from a leg to the hypotenuse, then you're timesing by square root of 2. Like times, or, you know, you kind of get it? Get what I'm saying? Like this is times. Times if you go from a leg to the hypotenuse, but divide if you go from the hypotenuse to the leg. And you should have definitely learned this in geometry. This should be review. I know they spent a lot of time on this in geometry. So we got to practice some down here and see if you can get this relationship figured out. So across from, I always look for the 30-degree angle. So across from the 30 is the short leg. So I can see it, that's the short leg. Okay, what's the 8? Is it the long leg or the hypotenuse? Yeah, the 8's the hypotenuse. Okay, so the hypotenuse on these kind, the hypotenuse is twice as long as the short side. So, how much is this short leg?
4.
Yeah, you got it. It's 4. Now we're supposed to find the long leg. Do you know what the answer is for the long leg? Yeah, it's 4 square root of 3. That's it. Good job. See, don't make it too hard. It's just take whatever the short side was and times it by square root of 3. That's not. You just write 4 square root of 3. Yep. Yeah, we leave it in radical form. Yeah, we don't put decimals. We just leave it in radical form. Okay, so here's another one. This one's a 45, 45, 90. Because it says 45 in the corner, it has to go with this picture, something like this. So they gave me the 6. The 6 is the hypotenuse side, the long side. So how am I going to find a leg? I'm going to divide by square root of 2. So I have to take the hypotenuse, the 6, and I have to divide it by square root of 2. See, like fraction, divide it by square root of 2. And I showed you on the front, you can't have square root of 2 at the bottom of a fraction. So you have to rationalize it. You have to divide by square root of 2 over square root of 2. So it becomes 6 square root of 2 over 2. 6 square root of 2 over 2. Well, that can reduce to 6 to 6. The numbers are not in the box. The 6 and the 2 reduce. Not the box, not the radical 2, but the, so you know what the final answer is? Yeah, 3 square root of 2. That's the answer. 6 divided by 2 over 2. That 2. This 2 goes into 6. Yep, so that leg is 3 square root of 2. X equals. Okay, let's try a couple more and then we'll be done. So here's another picture. A 30-60 picture again. So across 30, that's the short leg. The short side, the short leg, however you want to say it. And we're supposed to find what? Are we trying to find the long leg or the hypotenuse? This side of the 90 is called the hypotenuse. So what do you think? The answer is? Say it again. Did she say 100?
She said 1 before.
Oh, no. Short side to the hypotenuse. What do you have to do? Times it by 2. So what's the answer? 24. Yeah, x equals 24. Twice as long. Hypotenuse is twice as long as the short leg. It was just 12 times 2. You're kind of getting the hang of it? Okay, let's try the picture. So that square means 90. This means 60. It says 60. So wouldn't this be 30? You know, they didn't draw in there, but it's obvious. You know, 30, 60 triangles. It has to be 30 because triangles are 180. It has to be 30 in there. It's going to be like 90, 60, and something. Always going to be like 30, 60, 90. Okay, so I drew that 30 in there because I'm just trying to like highlight and reiterate. So this side over here is the short leg. I try to label those for you to help you out. Think about when you're doing your, like, label this, it might help you. So short leg. What's the 12? Is the 12 the hypotenuse or the long leg? Yeah, it's the long leg. See where the 90 is? The hypotenuse is always across from the 90. So this Y is the hypotenuse. Yeah, the 12 is the long leg. It helps to label those. You have to know which one's which. Ooh, this one's kind of tricky. This time it told us long leg. Alright, so let's go back to our original picture. It might help. So again, I think it's easiest, you know, if you have the short side and you're going like this way, then you like had to times by 2, you know, times 2 to get the hypotenuse twice as big. But if you go the other way, you divide, right? Same thing here. If you go like if you have the short side and you're going to find this, then you times by square root of 3. But if you're going from the long leg, if you have the long leg and you have to get the short leg, you have to divide by square root of 3. If you go this way, you have to divide by square root of 3. So you got to think through. So it might put, I don't know, arrows. Hopefully that helps you a little bit. If you're going from one side, short, to long side, then you times by square root of 3. But if they give you the long one and you got to go this way, you have to divide by square root of 3. So that's what's going on. They give you the long leg. So if you have to find the short leg, you have to take that 12 and you have to divide by square root of 3. So you're going to have to rationalize it. You have to times by square root of 3 over square root of 3 and then get your answer. And simplify and reduce. So you should 12 square root of 3 over 3, but that reduces. Do you know what the final answer for that is?
4.
Yeah, it'd be 4 square root of 3. That's your short leg. Yep, that's your short leg. 4 square root of 3. So then, what's the hypotenuse? And this Y, the other missing side. Take that, what we just got, yep. Times it by 2. You know what that would give you?
Oh, wait.
Take this without a calculator. What do you give you times this by 2?
Oh, 8.
8 square root of 3. The square root part stays the same. It's just like 4 times 2 is 8. 8 square root of 3. The radical stays the same when you times by 2. Okay, last one. $45, $45, 90 triangle. They gave you one of the sides is 5. Find the other sides. Oh, what do we think? What do you think? Which side do you think is easiest to find? Yeah, E is 5. On these the 2 legs are the same. Because they're the same angle as 45, so they should be the 2 same sides. If you have 2 angles that are 45, you'd have 2 sides the same. So what do you think for C?
Don't you just times it by 2?
No?
5 square root.
5 square root of 2. Yep. Answer. 5 square root of 2. Alright, so that is a skill you're supposed to learn in geometry. Depending on where that fell last year, I don't know. COVID, maybe. Maybe you can do it because of COVID, but you might have. You guys think it fell last year? You're sure?
It looks
I know, last year was the weird year of COVID, so that should have been geometry, but maybe it was at the end of the year. I don't know. I'm not sure. It's really not too bad. You just got to know if you're going to times or divide. So hopefully that pictures help you. So we're going to try a worksheet on that today. Yep, and the first part of the worksheet is these opposite, hypotenuse, adjacent stuff, and then you get to the special triangles. We call them special right triangles because it's always like a relationship like that. Yeah, I'm not really sure if COVID, if they learned that or not. They should have, but hit geometry. I don't know. It's not that bad though. I know, now you think like, yeah, they should know this, and then you're like, well, I don't know.
Yeah, it's COVID.
COVID.
Yeah.
Can we get that?
Extra?
Too many. So yeah, like when I start doing these guys, I like look where the little angle symbol is and I draw an arrow, so this side's opposite. It does help if you draw like an arrow across, so that has to be the opposite.
Here's another extra.
Oh yeah, somehow that row got lost then, huh? I don't know. You have opposite. So we got to find the hypotenuse, like find the C. A squared plus B squared equals C squared. There we go.